Hello students. So we'll be starting with the last section of this number system, that is the fraction and number system. The fraction based number system is same as what we have discussed already. First, here we'll be covering only mainly two topics, that is the binary fractions and octal fraction related fraction number systems. So we have already discussed the different number systems where we had the decimal, binary, octal, hexadecimal and so on. So you already are aware of this, and we had discussed the Bayesian number system where we had least significant and most significant digits written in this format. Then these are the real positive number, B is the digit, Q is the base value, and 6. So now coming to binary fractions. So you are already aware with this initial part where we have base 10 and base 2, where this 1101 base 2 is written as 1 into 2 to the power 3, 1 into 2 to the power 2, and 0 into 2 to the power 1, and 1 into 2 to the power 0. Now, the same thing in base 10 is 1 into 10 to the power 10, 10 to the power 1 plus 3 into 10 to the power 6. So 13 is equal to 1101 base 2. Now, when it is fractional, here it is a different thing. Here we are dealing with something like 0.625, which is made of 6 into 10 to the power minus 1, 2 into 10 to the power minus 2, and 5 into 10 to the power minus 3, which corresponds to 6 into zero point 0.1, 2 into zero point 0.01, 5 into zero point 0.001, based on minus 3, minus 2, and minus 1. So in the same lines, in binary, this corresponds to 1 into 2 to the power minus 1, which is 0.5, 0 into 2 to the power minus 2, which is 0.025, and 2, 1 into 2 to the power minus 3, which is 0.125. To make it more clear, let's go to the second part. So this is what we were dealing with. In binary fractions, we have something like 0 point here. Then we have 1 into 10 to the power minus 1, 1 into 2, 1 into 10 to the power minus 3, 1 minus 4. So here we are having 0.5, 0, 0.125, and 0.065. When we add them up, this 5 is here, 6, 2 and 5 is 7, 6 and 2 is 8, and 5 and 1 is 6. So 0.1011 base 2 is 0.6875 base 10. The fractional number system in decimal and binary, if you compare, you can have a full 1, 2, 3, 4, 5, 6, 7, which is written in this format in decimal, and in binary, this corresponds to 0.01325 like this. Now converting this decimal to binary, what we have here is that we just take 0.8125 in the reverse process. We just take this 8125 multiplied by 2, we get 1.6. So this 625 and we have a carry of 1, which is the MSB. Then 625 into 2, same thing. Then 0.25 we have remainder 0.5, so it is 0. Then finally 0.05 multiplied by 2 is 1, so let's. So 0.8125 base 10 is 0.11012. So we have done this, and if you want to cross check, you can cross check in this way. 0.5 plus 0.25 plus 0.625 will to 8.8125. So you can see from decimal fraction to binary fraction also we can do this way. Now binary fraction example, say we have a big number 54.6875. If you want to deal with this, what we do is separate this into two parts. This 554.6875 is 2 parts, 54 base 10 and 0.685, it's 0.6875 base 10. 54 base 10 is equal to 110102. How? This way, 54 divided by 2. This you already have done when we are discussing the binary number system. And this 0.1011 is multiplied by 2. So here in one side we are doing divided by 2, and in this side we are doing multiplied by 2, just the vice versa of each other. So in total what we get, 0.5 is 10 is, in this one it is 110 110, and after decimal we have 1101. So here we take it from MSB here to LSB, here we come from MSB to LSB. So in this case we take it 110110 this side, whereas here we come down as 1011. So it's something like circular thing. Next, for octal, it's a similar process. If we want to convert this to an octal number of this, we have 4 steps. First step is dealing with writing the octal weights based on thing in this format. Next, we go for this, assign the value of the weights starting from LSD from this format. So 407304 is put here 407.304. So these will be multiplied with the multipliers. Step 3 deals with compute the product of individual octal digits as the following. 3. Next, the last step is having individual product separated by octal point as illustrated below. So you can see 4 into 0, 7, 0. This is the MHD, this is the LSD part. So we have it 263. So I hope you are aware of the whole system that we have discussed here in number systems, binary, decimal, octal. Here I have not taken up hexadecimal number systems fractions, and I have avoided it because it will bring in the complexity. And you know that in the other two, the binary and octal are smaller than base 10. In the other way, it is just hexadecimal can be used as octal number system or a binary number system by grouping the digits. So I'm not going into that. Thank you, and hope if you have any queries, your relevant teachers will be taking that up. Thank you very much. Thank you for your patience, and I would like to sign off here on a good note.